Hello, I'm McLean,
And I'm Talita.
and we will present some history about the American physicist Albert Michelson and explain the 1877 Michelson-Morley experiment regarding the speed of light, as well as to discuss the global positioning system as an everyday application of their work. One fun fact about Albert Michelson is that he was an American physicist who studied in Europe and in the United States. He was a professor of physics at Clark University in Worcester, Mass., the city right next to ours.
Albert Michelson is well known for his work to determine the speed of light and the Michelson-Morley experiment concerning the effect of the ether drift and the speed of light. Albert Michelson became the first American to receive the 1907 Nobel Prize in Physics for his optical precision instruments and investigations carried out with their aid. Michelson also received 7 other notable prizes and medals for his work in physics.
In the early 1800s, it was believed that light required a medium through which to travel, just like sound requires a medium to carry sound waves. It was thought that an invisible medium existed, called the ether, whose only physical property was to allow light to move through it. Michelson and Morley set out to prove this hypothesis. The idea was that since the Earth and the ether were in relative motion rotating around the sun, that the speed of light would be different going with the ether than when the Earth was perpendicular to it.
To show this effect of the ether on the speed of light, Michelson and Morley constructed an interferometer, an optical instrument of extremely high precision to use for this experiment. In their experiment, Michelson and Morley were unable to measure any difference in the speed of light, traveling with or at the right angle with the ether. The light beams took the same amount of time. Therefore, they were unable to prove the existence of the ether, so light traveled at the same speed no matter its direction.
Michelson's findings regarding the speed of light, which he accurately determined using rotating mirrors to be 2.99 times 10 to the 8th meters per second, are the basis for many of our high-speed technologies of today, like mobile phones, ATMs, and the global positioning system, also known as the GPS.
The global positioning system, as we commonly call the GPS, is a satellite navigation system that provides digital maps of locations on Earth of longitude, latitude, and altitude, as well as time information. The GPS system was developed by the U.S. Department of Defense.
Even though the speed of light is so fast, almost instantaneous, in that radio waves sent from satellites move at the speed of light, you might think that there could never be a problem created by differences in radio signal speed, but there is.
It turns out that because GPS satellites are orbiting an altitude of about 12,000 miles from the ground, and because they are moving at about 9,000 miles per hour, the time they measure in space is different than the time here on Earth. This is due to what Einstein called relativistic changes, based on his special theory of relativity.
The system using atomic clocks aboard each satellite can only work correctly if time is measured perfectly, that is, within about 20 nanoseconds. Each nanosecond is only 1/billionth of a second. The combination of speed and altitude makes the clocks in the satellites tick faster than identical clocks on the ground. This would throw off the time measurement by about 35 microseconds a day, or 35,000 nanoseconds. This would be a problem.
So, to keep everything right and ensure accurate navigational fixes, the U.S. Air Force has to adjust the tick rate of the clocks orbiting in space a bit slower. Otherwise, the system would indicate data in just a few minutes. See, relativity is at work every time you use your smartphone or a GPS to direct you to that special location.
Thank you
and
goodbye
goodbye.
from McLean.
And Talita.